Y'all, it's Sean the Math Swap Tutoring, and in this video, I want to talk about implicit differentiation. All right, now, so first of all, let me give you the definition. I like to define words, and I want to define implicit. So when something is implicit, that means it's basically like implied. Um, even though it may not be obvious. Whereas, and my handwriting is better than that. Whereas explicit, which is the opposite of that, is basically something that's very obviously stated or obviously put. Okay. So, like if somebody is very explicit with the way that they feel, then that means that they're very obvious, they're very clear. Whereas that's implicit is implied. Okay. That said, let's actually talk about implicit differentiation. Now, typically, or a lot of the equations that we're kind of used to taking the derivative of or differentiating, you will have a variable which is explicitly defined in terms of another variable. For example, if you look at y equals x plus 1, in this situation, y is explicitly defined in terms of x. Okay, so it's very clear that y is equal to x plus 1. It's explicitly being defined in terms of the other variable x. Other equations, however, may be explicitly, or I'm sorry, implicitly defined um, by a relationship between two variables. So, for example, if you have this equation, here's a couple of equations here. So, if you have x squared plus y squared equals 36, or you have um, x cubed plus y cubed equals, um, let's say, 8xy. Okay, so x squared plus y squared equals 36. Of course, that looks like the Pythagorean theorem. Um, but this this is an equation that is not defined explicitly, but there is in this equation x squared plus y squared equals 36. It implies that there's a relationship between x and y. Okay, now and that also can be the equation of like a circle. Um, x squared plus y squared equals r squared, if that sounds familiar. Now, same here with this other equation, x cubed plus y cubed equals 8xy. Again, there's not an explicit uh, definition of x in terms of y or y in terms of x. However, you see that there is some sort of relationship that when x cubed is added to y cubed, then you get 8 times x and y. So there's that implicit definition. Okay. Now, sometimes implicit functions can be defined explicitly. In other words, sometimes you can take an implicit function and define it explicitly. Okay, so like for example, so let me actually write that. Sometimes an implicit function can be defined explicitly. Okay, so for example, if you look at um, x squared plus y squared equals 36, you can actually, to define it explicitly, that means you solve it for a variable. You can solve this for a variable pretty easily. So y squared, if you move the x squared over, y squared will be equal to x squared, I'm sorry, 36 rather. Oops, Let me erase that. 36 minus x squared. And then if you take the square root, then what you have is y equals plus or minus the square root of 30. I'm thinking and not writing what I'm thinking. 36 minus x squared. So you see that's two separate functions. Y equals square root of 36 minus x squared. Y equals negative square root of 36 minus x squared. So, and then you could from there, you could, if you want to differentiate, you could differentiate um, using the chain rule. Okay. However, other functions like this one here, x cubed plus y cubed equals 8xy, are difficult to define explicitly. And if you want to differentiate them, it would be easier to differentiate them using implicit differentiation. So, and are, I'll say this, more easily differentiated using implicit differentiation. Differentiation. Okay. All right. Now, so all implicit differentiation is um, you're able to take the derivative um, with respect to x, and then you solve for dy dx. Okay, so it's two steps. So the two steps of implicit differentiation. The first step is um, take the derivative with respect to x. Second step is solve for dy dx. Okay, so that's the two steps of implicit differentiation in a nutshell. It's not really that bad at all. Okay, so now what we're going to do is we're going to actually differentiate these two functions that we put here. X squared plus y squared equals 36 and x cubed plus y cubed equals 8y. Okay, so let us look at the following equation: x squared plus y squared equals 36, and we want to find dy dx. Okay, so just like I said, the first step is going to be to differentiate with respect to x. Okay, now this is where you also have to remember the chain rule, so we'll talk about it as we go. So you're going to take the derivative of both sides with respect to x. So this looks like this: dy dx, I mean d dx of x squared plus y squared equals the derivative with respect to x of 36. So now we're going to take the derivative separately of each of these terms. So d dx of x squared is going to be 2x, and then the derivative with respect to x of y squared, we're going to take we're going to use the chain rule, which is the derivative of the outside times the derivative of the inside. Okay, so that's going to be plus 2y dy dx. Okay, so again, that's because you take the derivative of the outside, which is just n times y to the n minus 1, and then you're taking the derivative of y, which is dy dx. That is equal to the derivative with respect to x of 36, which is just 0. All right. Now, since we're trying to find dy dx, we're actually going to solve for dy dx. Move this to the other side. Okay, 2y dy dx equals negative 2x. Divide both sides by 2y. Okay, and dy dx is equal to negative x over y. All right, so we implicitly differentiated, and we found that the derivative with respect, dy dx rather, is negative x over y. All right, next equation, x cubed plus y cubed equals 8xy. We want to, again, find dy dx. In other words, we're going to implicitly differentiate. All right, so the first step is to differentiate with respect to x. Okay, so the derivative with respect to x of x cubed plus y cubed equals the derivative with respect to x of 8xy. Okay, so we're going to do some chain rule here, some product rule as well. All right, so the derivative with respect to x of x cubed, that's going to be 3x squared, okay, plus the derivative with respect to x of y cubed, that's going to be 3y squared dy dx. That is going to be equal to the derivative with respect to x of 8xy. So this is how I'm going to treat this. This is the first thing being multiplied by the second thing. So the first times the derivative of the second plus the second times the derivative of the first, product rule. So the first times the derivative of the second, derivative of y is going to be dy dx plus the second, which is y, times the derivative of the first. The derivative of 8x is just 8. Okay? Now let's keep on going. Remember, we're trying to find dy dx, so we're going to solve for that. So we'll clean it up here in a second. Actually, let me go ahead and this is what I'm going to do. I'm going to go ahead and write y times 8 as 8y. Okay? Now, I'm going to go ahead and move some things around so that I can have all my dy dx's on one side and everything else on the other side. So we're going to subtract 8x dy dx from both sides. And I'm going to move 3x squared to the other side. Okay, so that goes away there, that goes away there. Now you have 3y squared dy dx minus 8x dy dx is equal to 8y minus 3x squared. Okay, factor out dy dx. Yeah, so I do it this way. I do it down here. Dy dx. When you factor that out, you're left with 3y squared minus 8x equals 8y minus 3x squared. We're going to divide both sides by 3y squared minus 8x. Okay, and that will give us dy dx equals 8y minus 3x squared over 3y squared minus 8x. And now we have found the derivative with respect to x of the function. Okay, so hopefully you tried these and saw if you got them right. Not much to implicit differentiation. Main thing is you just have to remember the chain rule. Let me know if this was helpful and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.